Hello scholars, this is Mr. Lowe. I hope all is well with you. Today's video lesson is on section 8.2, which is graphing rational functions. So this is the last section of unit number 8, which deals with rational functions in general. So to graph a rational function, there are a couple of concepts that we need to learn first. And we're going to do this using the graph that you see on the left. So the graph that you see on the left is a graph of a rational function. Notice that there are two separate curves that I'm tracing here in black. So all rational functions have two separate curves to them. One on top, one on bottom. Sometimes it will be in the top right and bottom left. Sometimes those curves will occur in the top left and the bottom right. It just depends on the function. However, the two main things that I want you to pay attention to are what's called the vertical asymptote and the horizontal asymptote. So the vertical asymptote is a vertical line where the graph is undefined, where the graph doesn't exist. So this is in red. So this is the vertical line that you see in red. So that vertical dotted line means that that graph cannot cross that line. That graph cannot cross that line on the x-axis. The other dotted line is called the horizontal asymptote. The horizontal asymptote is the horizontal dotted line that the graph cannot cross. The horizontal dotted line that the graph cannot cross. So vertical asymptotes are always labeled as x equals some number. X equals some number. The horizontal asymptote is y equals some number. So let's show using an equation how you would solve that out. So let's say that we are given the equation y equals 2 over x plus 3 minus 1. Y equals 2 over x plus 3 minus 1. So to find the vertical asymptote, you take the denominator and set it equal to 0. So take x plus 3, set it equal to 0. And of course, you would solve that out. Subtract 3 on both sides, so x equals negative 3. So x equals negative 3 is your vertical asymptote. Your vertical asymptote. In other words, you cannot plug in negative 3. You can't plug negative 3 into this problem. Earlier in this unit, we learned something called excluded values. That's the excluded value. You cannot plug in negative 3. For the horizontal asymptote, you look for the number. You look for the number behind the fraction. Look for the number behind the fraction. So that number behind the fraction is negative 1. So your horizontal asymptote is y equals negative 1. So what does this mean exactly? It means that since I can never plug in negative 3, I will never get negative 1 as an answer. Since I can't plug in negative 3, I'll never get negative 1 as an answer. That's what that means. So we have vertical asymptote, horizontal asymptote. The domain and the range are based off of the vertical and the horizontal asymptote. So the domain is based off of the vertical asymptote. It's a very easy way of representing what can you plug into the problem. So the domain is all real numbers, comma, x cannot equal -3. So all real numbers except x equals 3. X equals -3. You can plug in whatever number you want except for -3. That's what that means. Your range is based off of the horizontal asymptote. So it's written the same, written very similarly. All real numbers, y cannot equal -1. Y cannot equal -1. So vertical asymptote, take the denominator, set it equal to 0, solve it. Horizontal asymptote, look for the number behind the fraction, take it as is. The domain is based off of the vertical asymptote. The range is based off of the horizontal asymptote. So if you can find those 4 things, then doing a graph is actually not going to be that difficult. Because a good chunk of this can be done using a graphing calculator or using your scientific calculator, provided that you're given some points. So let's look at our first graph example. F of x equals 6 over x. So remember, this is the same thing as y equals 6 over x. Same thing. So step 1, find the vertical and horizontal asymptotes, draw them on the graph. So remember, vertical asymptote is denominator equal to 0. Denominator equal to 0, so there's your denominator. So x equals 0. Nothing to solve, nothing to move over, so x equals 0 is your vertical asymptote. Horizontal asymptote is, remember, look for the number behind the fraction. Number behind the fraction, so y equals 0. There's no number sitting behind the fraction, so since there's no number there, it's 0. No number there, it's 0. So there's your vertical and horizontal asymptotes. Vertical and horizontal. That's step 1. Now, to draw them on the graph, very simple. So remember from first semester, x equals a number is a vertical line. So go to x equals 0, go to your x-axis, find x equals 0, and you draw a vertical line through it. Now, my line is a dotted red line using colors to illustrate each part. If you want to draw a solid line, I could care less. So, horizontal line. So your horizontal line is y equals. So go to your y-axis, find y equals 0, and you draw your horizontal line. Draw your horizontal line. So those are the first 2 things that go on the graph. Step 2, find your domain and your range. So remember, your domain is based off of the vertical asymptote. So since vertical asymptote was in red, I'm putting the domain in red. So your domain is all real numbers, comma, x cannot equal 0. X cannot equal 0. The range is based off of the horizontal asymptote. So all real numbers, y cannot equal 0. So your vertical asymptote does your domain. Your horizontal asymptote does your range. So they link with one another. They link to one another. So now it's time to get some points on this graph. So notice in your notes packet, I've already put the table that your graph should have, but now let's show how we get that in a graphing calculator. So go ahead and take your graphing calculator out, those of you who have it. And you want to get to the screen that says y equals. So you press y equals and you type in the function. So the function was 6 divided by x. So 6 divided by x. Pretty simple. 6 divided by x. Now, we're going to take a sneak peek at the graph. So press graph, and it will give you a sneak peek of what it should look like. Notice that there are 2 curves. All of your rational functions should have 2 curves. Just in case you're wondering where the vertical and the horizontal asymptotes, graphing calculators, most graphing calculators will not draw them because, again, they're where the graph does not exist. So most graphing calculators won't draw them. If you have an older model graphing calculator, you might see it. But, so don't worry about it if you don't see those dotted lines drawn on the graph. Now, hit second and hit graph, and it's going to pull up the table. So the first primary thing you should notice is 0 and error. 0 and error. So the error is telling you where the vertical asymptote is located. So that's the vertical asymptote. That's the x value that does not exist. That's the x value that does not exist. So knowing where that is important. Knowing where that is important. So as far as plotting points, you need 6 points on the graph. You want 6 points on the graph. 3 of them on each side of the error message. So you want 3 points above it, and you want 3 points below it. Of course, you should be trying to plot some nice and neat points. So -3, -2 is a nice and neat point. -2, -3 is a nice and neat point. -1, -6 is a nice and neat point. So there's 3 above it. 1, 6, 2, 3, 3, 2. Those are nice points. 4, 1.5 could get plotted too. There's nothing really wrong with that point either. There's nothing wrong with that point. So on your notes packet, I've already taken a snapshot of this table. So we're going to go ahead and plot the points. So do this in green. So -3, 1, 2, 3, -3, -2. -2, 1, 2, -3. -1, 1, 2, 3, 4, 5, 6. And then draw your curve downward. Again, your points are curving downward, so it makes sense that you're drawing the curve down. 1, 1, 2, 3, 4, 5, 6. 1, 6. 2, 3. And 3, 2. And draw your other curve going down. And that's it. That's your graph. That's it. You're done with your graph. So most of the work will come in getting the points that you're going to plot. Doing vertical, horizontal asymptotes is actually pretty simple. Domain and range is pretty simple. Most of the work comes from getting the information out of the calculator. Now, side note, if you don't have a graphing calculator, then this is what would happen as it relates to a quiz or a test or things of that nature. You will be provided a table with the x values. You have to fill in the y values. So that's take each x value, plug it into the problem. Take each x value, plug it in, and you have to fill in the table yourself. Again, Algebra 2 trig, you are required to have a graphing calculator. So if you don't have a graphing calculator, guess what? You got to do more work. You got to do more work. That's simple. So that's example 1. Let's do another baby example, and then we'll graduate from there. So next example, f of x equals -4/x. So this is the same thing as y equals -4/x. So same rules apply. Vertical asymptote is take your denominator, set it equal to 0. So x equals 0. Nothing to solve there. You're good. Horizontal asymptote. You're looking for the number behind the fraction. Number behind the fraction, that would be that number right there, which isn't there. So y equals 0. There's your vertical and your horizontal. Go ahead and graph it right away. Horizontal, remember, is a left to right graph. So go to the y-axis, find 0, draw your horizontal asymptote. Vertical asymptote is vertical. Go to the x-axis, find 0, and draw your asymptote. So there's your 2 starting parts. Domain. Remember, domain comes from your vertical asymptote. So all real numbers. X cannot equal 0. X cannot equal 0. For your range, that's all real numbers. Y cannot equal 0. So we've got vertical, horizontal, domain, range. Let's go and grab ourselves a table. So go to our graphing calculator. Go back to y equals, clear out what was there. So we're going to type in -4 divided by x. -4 divided by x. Again, hit graph one time. You'll get to see where the curves should be. That gives you your sneak peek. Hit second and hit graph. Now we look at our table. So again, remember, the error message tells you where the vertical asymptote is. So you want 3 good points above it and 3 good points below it. So -4 and 1, -2, 2, -1, 4, 1, -4, 2, -2, 4, -1. Again, you want 3 on each side. You want 3 on each side. So we got our 3. So we're going to copy that table over. Always put your table. That way you know what you plot. Always put your table so that you know what you plotted. Putting your table is not optional. So then we plot our points. So -4, 1, -2, 2, -1, 1, 2, 3, 4. There's your curve. -1, 1, 2, 3, 4. 2, -2. 1, 2, 3, 4. -1. And that's it. That's your graph. That's it. That's your graph. So we did every single part. We did it a little bit quicker than we did the first graph. So now we got 2 graphs under our belt. 2 graphs under our belt. So next 2 examples. Next 2 examples. Now the denominator is going to be a little bit more complex. So it'll be x plus a number, x minus a number. Same rules apply. Same exact rules apply. So we have y equals -4 over x plus 2 minus 1. Same exact rules apply. Same exact rules apply. So remember, your vertical asymptote is take your denominator and set it equal to 0. So your denominator is x plus 2. X plus 2 equals 0. So that means x equals -2 is your vertical asymptote. Horizontal asymptote. That's the number behind the fraction. The number behind the fraction is -1. So your horizontal asymptote is y equals -1. Y equals -1. So once you have your vertical and your horizontal, go ahead and put them on the graph. So vertical asymptote, go to your x-axis, find -2, put your dotted line down -2. Horizontal asymptote was -1. Go to the y-axis, go to -1, and put your horizontal line. So there's your vertical, there's your horizontal. There's your vertical and horizontal. So remember, domain is based off of the vertical. So your domain, all real numbers. X cannot equal -2. Your range is based off of the horizontal asymptote. All real numbers. Y cannot equal -1. So there you go. Domain, range, vertical, horizontal asymptote taken care of. Again, for some of you, it will not take that long to get those 4 parts out. Now it's time to get the table. So when you get your table, since -2 was your vertical asymptote, in your table, you're going to see -2 and the error message. Yes, your vertical asymptote is always the error message. So you need 3 numbers above it and 3 numbers below it. So let's go ahead to the graph. So let's go back to y equals. So you got to be a little bit more careful this time around. Since you have x plus 2 sitting at the bottom of the fraction, here's how we type it in. You have -4 divided by, now you have to tell the calculator x plus 2. So open a parentheses, put in x plus 2. That's very important. You have to put in the parentheses. If you're going to do it right, you need to put in the parentheses. Then you put -1 behind it. So you have to be careful if you're using the calculator. The calculator is only as smart as the person using it. So if you type it in wrong, that's a you problem. That's a you problem. So let me show that one more time. -4 divided by, open parentheses, x plus 2, close the parentheses, and then -1. So now the calculator knows exactly what I want. Hit graph. It shows you your curves. Shows you what the graph should look like. Hit second and hit graph. -2. There's your error message. There's the error message that you want. Now you're looking for 3 good points above it and 3 good points below it. Three good points above and below it so that we can do our graph. Remember, those of you without a graphing calculator, these points would be, you would be given the x values, the y values you have to do on your own. So for our table, -6, 0, -4, 1, -3, 3, -1, -5, 0, -3, 2, -2. So let's plot these and finish off this problem. -6, 1, 2, 3, 4, 5, 6, -6, 0, 1, 2, 3, 4, -4, 1, 1, 2, 3, 1, 2, 3, -3, 3. Notice that the points are curving up, so your graph should be curving up. Your graph should be curving up. Then on the other side, -1, 1, 2, 3, 4, 5, -1, -5, 0, 1, 2, 3, and 2, 1, 2, 1, 2, 2, -2. And there's your other curve. So that's it. Problem's over. Vertical, horizontal, domain, range, table, plot the points, draw the curves. Find the domain and the range. Find the vertical asymptote and the horizontal asymptote. Find the domain and the range. Get your table, plot the points, draw the curve. So how long it takes, it's on you. How long it takes depends on how long it takes you to get each of the parts. How long it takes you to get each of the parts. So let's do one more example together as we get ready to finish this on off. So 6 divided by x minus 3 plus 2. So this should be a solid line. So my apologies for not writing that clearer. 6 divided by x minus 3 plus 2. So run through everything. Vertical asymptote, take your denominator, set it equal to 0. So x equals 3 is your vertical asymptote. Horizontal asymptote is your number behind the fraction. So that's y equals 2. Remember, the number behind the fraction you take as is. So your domain, all real numbers. X cannot equal 3. Your range, all real numbers. Y cannot equal 2. So there's your vertical, horizontal domain range. So for some of you, that probably takes maybe 1 minute, maybe 2, maybe less, depending on who you are. Vertical asymptote. Go to your x-axis, go to 3, draw your dotted line. Horizontal asymptote. Go to your y-axis, go to y equals 2, draw your horizontal line. So there's your vertical, there's your horizontal asymptotes. Now we're ready to go with our table. So for the table, so remember at 3, you should have the error message. That means you need 3 numbers above it, 3 numbers below it. 3 above, 3 below. So go to our calculator. Go back to y equals, clear out what was there. So we're putting in 6 divided by parentheses x minus 3 close parentheses plus 2. Again, if you don't put the parentheses, then you're going to get a graph that's not correct. You're going to get something that's not correct. Remember, your calculator understands order of operations. So if you don't type it in the right way, then the calculator is going to do what you told it to do. And if it's wrong, that's a you problem. Press graph. You'll see what it looks like. Hit second and hit graph. So your error is down there, so you may need to use the arrow keys to move the table. But we're still looking for 3 good points on each side. So 3 good points above it, 3 good points below it. We can even use 0.5 if we absolutely needed to. We can use 0.5 if we absolutely needed to. So we've got 0, 0, 1, negative 1, 2, negative 4, 4, comma 8, 5, comma 5, and 6, comma 4. So we've got what we need. So again, copy your table. Copying the table is not optional. Copying the table is not optional. And then we plot our points. So 0, 0, 1, negative 1, 2, negative 4. There's your curve going downward. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. There's your other 3 points. That's it. Problem's over. So, just as I had mentioned, do your vertical asymptote, horizontal asymptote, domain, range. That's 4 steps. Get the table, plot the points, draw the curve. 7 parts. Now, of course, I'm showing it slower than how some of you all will do it. Some of you all will finish this problem in no time easily. But you have each of the parts now. Now you have each of the parts. So this finishes up the lesson for section 8.2. Of course, you rewind, fast forward, replay this video as many times as you feel is necessary so that you get the concept down. But do know you are now accountable for the learning of this concept. You are accountable for asking questions if you have them. With that being said, hope the video helps you out. Take care. Have a good one.